Hi, my name is Eric Staples. I'm an applications engineer with Microchip Technology, and in this video I will show you how to use the 1 megasample per second 16-bit differential input SAR ADC evaluation board, or ADM00873. First, you will need the ADM00873-BNDL 1 megasample per second SAR ADC evaluation kit. This kit includes the 1 megasample per second 16-bit differential SAR ADC evaluation board, or ADM00873, which includes the 1 megasample per second 16-bit differential input ADC and the MCP 6D11 differential input ADC driver. This board can measure both differential and single-ended input signals. Also, the ADC can use up to 5.1 volts for the reference voltage, but for convenience I will be using the onboard 4-volt reference voltage. The kit also includes the PIC32MZ Curiosity board. The Curiosity board communicates with the ADC on the evaluation board using SPI interface, collects the data, and sends it to the SAR ADC evaluation utility. The Curiosity board will come with firmware already installed, but the latest firmware can also be downloaded from the product webpage. The kit includes a 9-volt power supply to power the ADM00873, a micro USB cable for the Curiosity board, and the SAR ADC evaluation utility, which can be downloaded from the Microchip website. With this kit, you can measure DC voltage from sensors, high-frequency AC inputs from acoustic sensors, communication equipment, and much more. To begin, connect the ADM00873 to the Curiosity board as seen here. Make sure that the J8 jumper here is connecting VIN to VBus. Next, connect the micro USB cable from your computer to the Curiosity board. Then connect the 9-volt power supply to the ADM00873. Once these LEDs turn on, you're all set to launch the SAR ADC evaluation utility on your computer. I will now show you how to use the ADM00873 kit to measure AC and DC signals. When measuring AC signals, both single-ended and differential-ended options are available. To measure a signal differentially, connect the positive input signal to this SMA connector and the negative input signal to this SMA connector. Also make sure that this jumper here is not connected. For single-ended input measurements, connect your single-ended input signal to this SMA connector. Also connect this jumper here. This will provide a 2-volt reference voltage so that a single-ended input can swing from 0 volts to 4 volts centered at 2 volts. To measure a DC signal, connect the signal to the right side pin of the J6 header. Connect ground to any ground test point on the board and connect TP1 to ground. Here I've soldered TP1 to ground for convenience. Here's a closer view of how to connect your signal to the ADM00873 to measure a DC signal. You're now ready to analyze your signal using the SAR ADC evaluation utility. Once the utility is launched, you will see 4 main sections: Settings, Analysis, Results, and a plot of your signal. In the Settings section, you can choose the particular device from the MCP 331X1-XX family that is on your evaluation board here. You may also change the operating mode from continuous to single shot here. In the Analysis section, you can choose how to analyze your signal by changing the sampling frequency, spectral leakage, and so on. You may also change the domain of your signal from FFT to volts versus time, codes versus time, or INL and DNL. In the Results section is displayed a variety of performance parameters, such as the fundamental frequency and fundamental power, SNR, SFDR, and THD. You may want to consider using an input filter to improve your AC signal. To begin acquiring data, you can choose single conversion or continuous. Single conversion will give you one sample of your signal, while continuous will give you a continuous stream of data. Here's a quick demo for how to analyze AC signals using continuous mode. To begin data acquisition, click on the Continuous button. and to end, click on the stop button. I will now show you how to use the ADM00873 to measure DC signals. When analyzing a DC signal, it is most convenient to use the single shot mode. Before running a single conversion, you must input the reference voltage here. I am using the onboard 4-volt reference voltage, so I entered 4 volts. The utility will calculate the LSB here. The calculated input voltage will be displayed here, and the digital output will be displayed on the plot. These features are especially useful to firmware developers for debugging purposes. Here's a quick demo of how to analyze DC signals using single shot mode. First, go into single shot mode, then enter your reference voltage here, and then click single conversion. In this demo, we applied 3.92 volt DC at the input. The calculated ADC results says 3.9194 volts, which is exactly what we put in. You can use this evaluation board and GUI to easily measure any unknown input voltage, such as an output from a capacitive sensor, pressure sensor, vibration sensor, current sensor, and more. One of the greatest advantages of this measurement is that you can see the digital output codes of any known or unknown input. This is very helpful when working on system design and when developing MCU codes. Thanks for watching.